This video is to show you how to operate a polarimeter and use this to do experiment K2, which is the kinetics of the inversion of sucrose at various different temperatures, monitoring it by optical rotation. The reactant today is just plain table sugar. It's exactly what you'll find. You need to weigh out about 20 grams of it, and we place it in water. We want about 180 mils of it and add the sugar to it. This is going to make a syrup. It doesn't really matter if you get it all there or not. You're going to be measuring it later on. But stir this up until it's dissolved. Now, while we're waiting for that dissolution to happen, let me talk a bit about the instrumentation that we've got here. This is an AA55 polarimeter. It measures the rotation of plane polarized light. It operates the same principle as Polaroid sunglasses. Most light is scattered, that is, it is in all different directions. Plane polarized light has the waves of the light all moving in one plane. If you pass plane polarized light through a solution of a natural product like sugar, which is of only one optical conformation, then it will tend to rotate the light either to the left or to the right. In fact, sucrose, table sugar, rotates plane polarized light slightly to the right. When you add acid to table sugar, to sucrose, it will hydrolyze and become a mixture of dextrose plus fructose. And that mixture actually rotates light to the left. And so you can monitor the course of this particular reaction by observing how much the solution rotates either to the left or to the right. This machine is fairly simple. There's an on-off switch here, which I've just turned on now, and you can read it up here. Now, it'll probably give me a very funny number to start off with, but that's okay. Let's see how my syrup is going here. For any one reaction, we're going to want 25 mils of the syrup solution and 25 mils of 1 mole of sulfuric acid. So let's measure out the sulfuric acid first. There's my pipette bulb. Here's my sulfuric acid. We've provided you with 2 pipettes. Make sure that you don't mix the 2, because if you use the same pipette for both, you're going to start the reaction before you want it to. So, okay. All right. All of this to eye level. 25.0 mils. Touch the tip and dispense. Now, once I've got these 2 solutions ready to go, we're going to clamp them so that they are resting in a constant temperature bath. We've got several of these constant temperature baths sitting for the kinetics experiments. They're at different temperatures. And what you will do is have your solutions sitting in, and once your solutions get to temperature, then you mix them and start the reaction. So there's my sulfuric acid ready to go, and I will clamp this here. The temperature baths are preset at temperatures. Please do not adjust this. The other thing to point out to you is this sign here. You're used to marking flasks with masking tape. That works most of the time. It doesn't work if you're going to stick it in water. The masking tape will just float off and it will start fouling the pump. So please, instead of masking tape, use a marker to identify your flasks for what they are. Meanwhile, back at the sugar, I think we've got this ready to go. It's all dissolved, and I'm taking my clean dry pipette. I'll take the sugar solution or syrup and fill it up. There we go. You're not the only person using these hot water baths. There will be other people doing other kinetics experiments. So please do make sure that you identify your flasks as yours. 1, 2, 3 is not necessarily going to work. All right, there we have 25 mils. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Touch the tip. And we're ready to go. And place this also in the hot water bath. And we let this sit for about 10 minutes to make sure that it gets to the appropriate temperature. This is given some arbitrary reading, so I just push 0, and that resets the polarimeter to 0. The sample compartment is right here, and the sample container, the cell, actually sits in the gray holder like that. We will have to fill this shortly. I'll leave that open. This tube is actually exactly 2 decimeters long, and it has flat glass plates at either end. You open one of the ends, and that's where we're going to fill it in a minute. Right, let's just check that these are indeed at the appropriate temperatures. Yes, they are. Thank you very much. So we're now ready to start the reaction. And we do this by opening the clamps to get the flasks out. And then, when you're ready, pour one into the other, and you pour them back and forth between the flasks 3 or 4 times to get complete mixing. Take your stopwatch and start the reaction timing. Now at this point I have to fill the cell. Take this and, holding it vertically, pour your sample in. Yeah, it's almost getting there. I'm now to the stage I want to use a dropper. So taking a dropper and adding up, you want to fill it so that it's somewhat brimming there. The idea is to get a minimum amount of air in here and close that down. Okay. Now there probably will be a bubble, but you notice there's a fat part in the tube here, and the trick is to hold it horizontally so that the bubble is held in the fat part. And that way you will not have the air containing obscuring anything. Make sure that you dry the ends. Make sure that you can, if you look through it, you can see things rather than blurring. I'll show you that on camera in a minute. And then we put this into the container, and it's taking a little while to get there. 6.75. Now, we now take this cell and put it immediately into the constant temperature bath. And it sits there until it's time for you to read it again. This way, the reaction mixture, which is now inside the cell, will stay at the appropriate temperature. And when you're ready to take the next reading, about 30 seconds before the next reading, reach in and fish it out. Now this time there will be a fair amount of moisture on both ends. You're not too worried about the middle, but do make sure that you dry both of these ends. look through it, and I can see the brick pattern on the wall quite clearly. Pop it back in, and at the appropriate time, 90603, take the reading and put it immediately back into the high temperature bath. And you do that until you have gained the appropriate number of readings on each of the mixtures. We're going to have you actually start with a cool bath at 30 degrees, because that has more time in it. It moves more slowly. And then when you're used to doing that, you can do it in the 40 and the 50 degree baths, and those ones move quite quickly. For T infinity, that is the rotation of the equilibrium mix, you will use the high temperature one, and after 2 hours sitting in a hot bath, it will have equilibrated. Because you're making the same mixture of 25 mils of acid and 25 mils of sugar syrup, for each of them, the T infinity reading will be the same for all of your samples. When you have finished, all you need to do is take everything out, and it's just sugar and mild acid solutions. Everything gets poured down the sink, and turn off the polarimeter. But this reaction does leave a mess. It just looks like sugar solution, and to you and me it will be harmless. Unfortunately, if you spill this stuff anywhere, a week and a half later, it's going to be quite sticky, and bacteria invade, and it becomes black and gooey, and sometimes even fuzzy. So please make sure that when you are finished, wash everything with wet paper towels, including the sample compartment and everything else. Dump this and wash it well several times with distilled water, so that everything you leave is wet only with water and not with sugar solution. And that is how you monitor a kinetic reaction using a polarimeter.